In the last video I made talking about the OpenStack Dataplane Operator, I mentioned that I was working on some big changes to the API interface and things that would change the user experience. And we've since merged those changes along with some other changes from other people. And I thought it would be a good opportunity to basically remake that video to show how to interact with the OpenStack Dataplane in the new version of Red Hat OpenStack, given this new design. So in the old design, I mentioned we had the three controllers. We had the OpenStack Dataplane node, OpenStack Dataplane role, and OpenStack Dataplane. You could create the node and role independently, or you could just create the OpenStack Dataplane, which would then create the other two resources for you. So my change was really focused on consolidating the logic in the role and the node controller to provide a single consistent interface that we could then use for defining a node set, which is what we've called the new controller. It's the OpenStack Dataplane node set. On top of that, there were some other changes merged because we really wanted to separate the definition of your infrastructure. So defining a node set will go and provision the Baremetal and set up all the things that are required to provision those nodes, but then it will stop. And then you need to create an OpenStack Dataplane Deployment resource, which will then actually kick off the deployment of the OpenStack software onto those nodes. And that was something that was requested by users. It was a feature that we promised to deliver. So we've done that. We've separated those two lots of logic, and that's what we're looking at today. In addition to that, we also changed how you interact with the network configuration. So instead of providing a network config template in the spec network config template section, we're just using the Ansible variable directly, which is what we were doing anyway. We were just abstracting the Ansible variable away into the custom resource definition via the API. So we've removed that abstraction and now interact with that directly via the Ansible variable. So we'll look at that in this video today. We'll deploy an OpenStack Dataplane and we'll take a look at how it works now. So the first resource we'll look at is the node set. So this is what the node set now looks like. So in my case, I'm using pre-provisioned. If you aren't using pre-provisioned, you can provide all the information for the Baremetal operator to go and provision the nodes. This is just a virtual machine running on my server, as is everything in this lab. So I'm setting pre-provision to true. Now under node template, these are generic things that will be inherited by all nodes that are defined by this node set. So in my case, I'm using the same SSH secret for everything. That's a global variable that needs to be defined. And then under the Ansible section, we have Ansible vars. And here we can see that we define the EDPM network config template. Now this is the variable we were setting anyway when you provided that network config template via the spec previously, but we just felt the abstraction was a bit unnecessary. It meant more complex code on the back end, and ultimately it's basically the same user experience, just to define it as the Ansible variable, which makes a bit more sense for users, so hopefully a bit more intuitive there. So you provide the network config template. This is just an OS NetConfig template like it's always been. Then we have a bunch of Ansible variables here. We can just skip over them, they're not overly relevant. You can define any environment variables that you want to use in the environment. So if you wanted to enable Ansible verbosity of 4, for example, we can change it here, and that will give us more debug output when we create the resource in the Ansible task run. Then we have this node section, and this is where we really come down to defining things that are specific to an individual node. So in this case, EDPM compute 0, and I'm using this networks dictionary here. This is for IPM. So we use IPM on the back end to manage the IP addresses for your data plane within the Kubernetes cluster using IP sets. So this is where you would define, for example, the fixed IP of my control plane for the node is 192.168.122.12. And the other ones, I don't care about the other addresses, so we'll just dynamically assign addresses to those. Set the host name, and then any Ansible specific information for this node. So in this case, I have 3 interfaces on the node. I have one that I can access that isn't managed by OS NetConfig, and that's just so when I break things I can still SSH in without having to versh console into it. So that's this interface, and that's the interface I want Ansible to configure things over, and then it can configure its control plane interface on this IP address. And any other Ansible variables that you might like to define here. So if you had a specific network configuration for EDPM compute 0, but not for the other nodes, you could put the EDPM network config template variable here and define your specific configuration for this node here. So that's really it for the node. The other thing you can do is define services. So we have a bunch of default services that I will show. So you can see here in this sample file, this one's providing a list of services. So services are nothing more than the definition of an Ansible role that we want to include and deploy for this environment. So if we take a look at, for example, configure network, so this is what it looks like for the definition of the configure network service. So you can see all it's doing there is calling a playbook called EDPM configure network. So if you're a third-party integrator and you want to integrate your software with Red Hat's next generation of OpenStack, say you want to deploy Contrail, or maybe you want to use Nokia Nuage or some other provider and you need to run your own playbooks, this is how you would do it. You would write your own Ansible role, you would create a custom service, and then just include that in your node set. So just include that in the list and it will be deployed. So you can see there we do quite a few RunOS OVMs. We configure OVM, we configure libvirt, then we configure Nova, and finally telemetry. So that's the first resource we need to create, is the node set. And the next one is the dataplaneDeployment. And all that does is specifies which node sets will actually be provisioned once this is created. So in my case, it's EDPM compute, and you can see that that matches the name of my node set resource. So that's it. This is all we need to do now. It's quite significantly simplified compared to the last time we looked at this. So what we'll do is we'll just go and create those. So we'll create just the node set first, and we'll see what that looks like. So we can see it's created the node set there now, so we do oc get osdp ns. We can see that it says deployment not started, and that's because we haven't created the deployment resource yet. And if we have a look at what this now looks like, we can see that it includes that default list of services. We'll make that a bit easier to look at. So you can see it's included the default list of services, even though I didn't define them. That's just the defaults. So if you have anything in addition, then you can add it to that list. And everything else looks basically as we defined it. We can see here it did define the Baremetal node set template, which is what you can interact with if you have Baremetal nodes that need deploying. So this is going to stay in this state now until we create the deployment. So let's go ahead and create the deployment. So now we can see that the deployment's in progress. So we do oc get OpenStack Ansible EE. We can see it's now created a job for the download cache. So now if we go oc get PO, you can see we have all of our control plane stuff running, but we also now have this Ansible task that has been launched. So we follow along with the logs there. We can see it's just a normal Ansible output executing the playbook, and it's downloading all the packages that it needs, all the containers that it needs to do the configuration of OpenStack. So it's kind of just caching things locally to speed up the steps that will come after this. And if we look back at the osdp ns in the status section, we can see here that we have some status objects that are going to be changing as this deployment proceeds. So setup ready is true. Node set IP reservation ready is now set to true. So we do oc get IP set. We can see we have an IP set there. EDPM compute 0. And we can see this has the reservations that have been created for my node on the various subnets. So I gave it one for the control plane, so it's using the one that I provided there. Oh. And then the rest have just been pre-allocated to me from the pools that have been set up. Now all that information is coming from the NetConfig. So we do get NetConfig. We can see we have a NetConfig here. I'll show you YAML on that one. So we can see here that we've defined our subnets within this NetConfig, and it's just pulling IP addresses from those subnets that we've already defined there. So we go back to get PO. So now we have the configure network job that's been created, and we'll have a corresponding pod that's been created. And so these pods are labeled, so if you want to filter by them, you can just go oc get PO-L app equals OpenStack Ansible EE, and then we'll just see the pods that are related to these executions for our data plane. So again, we can just follow along with the logs here. And we take a look at the deployment resource, so OSDP deployment. We can see here it's telling us what it's actually doing at the moment. So configure network deployment is not yet ready. And then we have a list of node sets. So you could define multiple node sets. Maybe you have standard compute, you've got DPDK, you've got SRIV. You could then define all those node sets. And then when you're ready to deploy them, you could include them in a single deployment so that then they can be managed together. Or you could define them separately in different deployments. So it just takes a list of node sets that you want to deploy. If we take a look here, we can just see this would just be a list. You could just add to this list any number of node sets that you need to deploy. And again, similar thing here, we just have the status section that's reflective of what's actually happening at the moment in the cluster. So we're still waiting on the configure network job to finish at this stage. So configure network is now finished, and we got validate network running. So we have a look here. Oh, now it's on to install OS. So you can see this moves through pretty quickly now because it's already pre-cached everything. It's just a matter of now going and configuring the various things on the node. So if we follow along with this one. This one's configuring the operating system so that it's ready to run the containers we need to run to deploy OpenStack. And if we log into the node, so again, this is the interface that I'm using to manage it. So you can see here I've got the three interfaces, EMP1, 7, and 8. I'm using 8 for the control plane and EMP7 for all of the VLAN interfaces. So we go OBS, VS, CTO, show. We can see that sorry, I'm using EMP1 for the bridge, and EMP7 is the interface that I will use to log into it that's not configured in any of these bridges. So EMP1S0 is part of the BRX bridge, and then we have the VLAN interfaces that are coming off of that. So we can have a look at OS NetConfig, config YAML. So you can see this now exists. This has just been rendered from what I provided in that EDPM network config template file. So you can see there, that's where I add nic2, which just has that management IP address, and that's all it does. It doesn't do anything else to that interface. Just make sure that I'm going to be able to access it no matter what. And if you want to know what maps to nic2 and nic1 and nic3, you can do os netconfig-i, and that will tell you what the interface is actually mapped to when you're writing these network config templates. So we'll go back, we'll see what this is up to now. So we can see there we've got configure OS. So this moves pretty quickly. This will all happen pretty quick, and if you have multiple nodes, it's obviously going to happen against multiple nodes at the same time. So if they fail, they have a retry limit, and it'll just keep retrying. So if you have an issue with your network configuration, for example, and it can't ping the gateway, you have a little bit of leeway there where you can log into the node, see what the error is, maybe fix a networking issue, or come back and change your template and have it redeploy it. So that's really all there is to it. It's basically, from this point, it's just a matter of monitoring those status fields. So the data plane deployment at this point will have the most information for you. So you just YQ, and then you want to filter on items because we didn't specify the name. status. So you can see there, it's just going to keep filling up this status conditions section until we complete the deployment or fail, and either way it'll be reported here. So it's pretty easy to get an idea of what's happening within the cluster. If you need to check any logs for what the operator itself is actually doing, we can see here we have the Dataplane Operator Controller Manager, and this is where all the logic is happening, where all this stuff is being, like the Ansible execution environments, all that's being created. So we do see logs on that operator pod itself. We can see here that this goes through and it's waiting for the Dataplane Configure OS, Dataplane Deployment Configure OS EPM compute. So you've got the name of the node set in there. So it's easy to reference from these logs as well if you need to check any logs and find any relevant information about failures that might happen. And then it's just saying not all node sets are done yet. So it's just going to keep looping until it either completes or fails and then report that error to me. So that's it. That's the changes we've made to the OpenStack Dataplane Operator since the last video I made. As you can see, it's quite a lot more simple now, hopefully more intuitive for users to interact with. There's not as many layers of abstraction. There's not as many resources that you need to care about. And if you're an integrator, we've got a nice interface there for you to write your own playbooks and list them in the services list to have your software configured on the nodes. So if you're a storage provider and you've got a SAN that you need to configure access to, or if you're a CNI provider and you've got an ML2 plugin that needs configuring, like Contrail or something to that effect, you can do that by writing your own Ansible playbooks and listing them in the services. Or even if you're just using your own monitoring solution that isn't supported by Red Hat, but it's ingrained in your business and you need to use it for your OpenStack deployment, you can write your own playbooks, create them as a service to call them, and then list them on your node sets, and it will go and provision everything you need. So hopefully you find it more intuitive as well. If you have any questions, feel free to ask me below. I'm happy to make more in-depth videos where we walk through the code or look at anything in particular you would like to see. I can deploy a metal cubed environment and show that bare metal provisioning process as well if that's something that you had a particular interest in. But otherwise, encourage everyone to go out, give it a try. Let us know what you think. We really want to hear your feedback, and we want to make this a really good solution that's intuitive and hopefully a better experience than what you've had before with Red Hat OpenStack.